For the last video today, let's count the number of words in a file. So let's copy count c.c to count w.c. And let's edit the file. Okay, we're going to do things a little bit differently this time. I'm going to introduce a new looping structure called do while, which is do following sequence of commands while some condition is true. As expected, the condition is going to be what we normally do. While we're not at the end of file character, we do the following. Okay, now this is where it gets just a little bit tricky. Words are going to be defined as a sequence of characters that aren't white space. Okay, white space is either your normal single space bar, a tab character, a carriage return, or a new line. And the idea is that the first time that you hit a word, we'll sit there and increment a counter, and that counter will be called NW. The rest of the time, we're simply just going through the word or going through the white space. So, a couple of changes we're going to make is, right at the beginning, we're going to initialize ch with getChar. We've initialized our number of words variable to 0, and we're going to introduce another variable called whitespace and initialize that to true. That will tell us that we're actually chopping through whitespace at the time, and you'll see why we do that in a second. Okay, if our character is single space, or, and vertical bar represents or in C, ch is equal to the tab character, or ch is equal to the new line character, or ch is equal to the carriage return character. Carriage return and new line are separate characters. If that's the case, then we simply say that white space equals 1, which means we're chopping through the white space. Else, if the following, white space equals 1, NW equals NW plus 1. What do we mean by this? Okay, what this means is that we're not at this stage of the code. We are definitely not encountering white space, and yet the white space variable is still 1. That means that we've just encountered a word, some non-white space character. When that happens, we increment our word counter by 1, and then we set our white space flag to 0. And then because this is a do loop, we have to keep updating the character, so character equals getChar is the last thing that we say. Finally, number of words. It's simply this. Okay, let's compile this and try it out on Voyage of the Beagle. Now let's see what Linux says. Good, they agree. Now I'd like to make a couple more changes to the code to make it a little easier to read. I don't particularly like to have flags be set to 1 or 0. It's not terribly mnemonic. So we're going to introduce a new construct called the define statement. And I'll tell you what that does in a second. Okay, defining true to be 1 and defining false to be 0. True is not a variable and false is not a variable. What's going to happen is that every single time we use the word true or false in the code, the compiler will substitute the values 1 and 0 in for you. But it just makes the code more readable for us. It doesn't matter to the compiler. So white space equals true there, white space equals true here. We want to compare white space to true here, and finally we set white space to false. Okay. This just reads better for the humans. While we're in white space should be set to true. Otherwise, we set it to false. Again, these are not variables. These are textual substitutions that the compiler does right before compiling. Every time it sees a true, it puts a 1 in place. And every time it sees a false, it puts a 0 in place. Let's compile. Again, we'll double check. And everything agrees. So we've learned quite a few things here. Okay, the first one is an addition of a new character, the carriage return character denoted by \r. The use of a sort of state variable flag in our code, which tells us whether we're eating up white space or not. The do loop is a new looping construct for us to use. And I think that does it for this lecture, so we'll take a break for the evening.